Okay, so for a couple of seconds, for some reason, I did not record this video audio. I'm so sorry. So we're looking at x to the power n, and we're going to practice this, a constant times f prime, f plus g, and then we were looking at the product and quotient rules. 1, 2, 1, 2, 1, 2, 1 prime 2 plus 1 times 2 prime. And the same thing with the quotient. Sorry, for some reason, I'm not sure why the camera didn't record. Last minute or two. Okay, I'm ready for you to choose. I'm going to share my screen. And I'm going to, let's go first to 1.5, and that's page 145. Where's my keyboard? I got it. 145. Okay, so let's choose from there anything you want. Anything. Choose freely.
19.
19. So let's start with 19. Very good. Where are you? 19. Very good. 19. So we have y equals negative 4.8 times x to 1/3. Okay, I'm going to stop sharing. So this is a constant times a function. The power goes in front and multiplies this number. So y prime will be negative 4.8 times 1/3 times x. From 1/3, I subtract 1. Remember, we need a least common denominator, etc., etc. So it will be negative 2/3. Negative 2/3. I have to perform this product or quotient, whatever you want to say. So this will be negative 1.6. So negative 1.6. This you can bring to the denominator if you want, or you can just simply leave it as is. So this is the derivative function of this. If you want to determine the rate of change of this function at any point except 0, you notice that when you put this in the denominator, you cannot plug in 0 in it. Other than that, you can plug in anything. So this function is not differentiable at 0. How come? If you graph, this is a number, doesn't matter. But if you graph the cube root of x, if you remember how to graph the cube root of x, you will see what happens. Can anyone explain what happens at 0? Why do I claim that this function is not differentiable at 0?
Vertical tangent at 0.
Very good. Vertical tangent at 0. Same thing, you can see it by simply changing the negative power into positive. How come? If you write negative 1.6 over the cube root of x squared, you will see this is in the denominator. It cannot be 0. So that's another way. Okay, the derivative doesn't exist at 0, which means this function is not differentiable at 0. Very good. Good pick. I'm sharing my screen. I'm sorry about my phone. I'm going to make sure it's shut off. Okay, anything else you would like to choose from here? Let's see the next page.
Can we go back and do 30?
Yes, of course. Let's go back and do 30 right here. Yes, thank you for reminding me. Okay, so let me copy it first. This is just a different notation. We're going to use both. Very good pick. Thank you, thank you, thank you. So f prime of x, or the derivative of the function with respect to x, mean the same thing. So this is like the derivative of a function with respect to x. It's just a different notation. This is called the Leibniz notation. Okay, so I'm going to differentiate, bringing 2 down, multiply by 6. So I get to 12x. And when I differentiate this, the derivative of x is 1, or just the slope of this function is negative 5. And this is it. Good pick. Thank you for pointing that out. Okay, let's see what else. Okay, so let's look at something like this. Just pick anything you want from here. So we can have all types of problems. You'll see in a moment.
53.
53 it is, very good. So let me copy 53 and I'll stop sharing. So this is y equals the cube root of x plus the square root of x. Excellent. And then they're asking us dy over dx at x equals 64. Perfect, perfect. Okay. So first of all, let's analyze what this means. See, when we have f prime, if I ask you evaluate f2, you will find f prime and then plug in 2. Well, we don't have the same type of notation here. We just use a vertical bar. And what does this mean is, well, after you determine the derivative of y with respect to x, evaluate it when x is 64. So this is much easier notation here. If we use dy over dx, then we have to write a bar that says, okay, evaluate it when x is 64. It's the same notation with this. But it looks a little bit more complicated, but it means the same thing. Find the derivative, plug in 64. For such a situation, this, I don't have any secret. I know that this will differentiate it, will give us what?
One over 2x. Or x squared.
Good. But for this one, I recommend changing it into a power first. X to 1/3 and differentiate it like that. For this one, we have a shortcut. We already know it. Now we have to dream about it. This is carved in stone. But for any other index, first change it into a power, apply the power rule. So let's do that. And this is my page 8. So first we change the function, not this one, just this piece, as x to 1/3 plus the square root of x. Now you can write y prime, you can write dy over dx. It's up to you. Bring down the power and subtract 1 from the power. We just did that. 1/3 minus 1 is x to negative 2/3. And this one is plus 1 over 2 the square root of x. Done. Now we're asked to plug in 64 for x. Okay, so this will be 1/3, 64 to negative 2/3, plus 1 over 2. And I know the square root of 64 is 8, so I'm going to write times 8. So here you have two options. The option that I like is to change 64 in 4 cubed. You can say, no, I just want to use TI calculator and get the answer. But 4 cubed raised to 2/3 will be 4 to negative 2, which is 1 over 4 squared, which is 16. 1 over 16. So it's up to you. So you can plug it in, 64, caret, in parentheses, negative 2 divided by 3. You're going to get a decimal number, which is not acceptable. Another possibility is to click on math and go to fraction and change it into a fraction. It's exactly what I just said, 1 over 16. But 0.0625 is not acceptable unless it's a word problem and whatever. So other situations. But here I have to write it as 1 over 16. So I'm continuing here as 1/3 times 1 over 16 plus 1 over 16. So here, what I'd like to do is factor out 1 over 16 because it's easier for me to just add these two fractions and then multiply. It doesn't matter really. So this is 4/3. So 1 over 16, and you have to multiply this by 3. 1 plus 3 will be 4. So 4 divided by 3, that is easier for me. and I get 1 over 12. What does this mean? This is the slope at that point with 64, and I did not calculate the y value. So the cube root of 64 is 4, 4 plus 8, 12. So this number is the slope of the tangent line to the graph of this function at the point 64, 12. Or is the rate of change, instantaneous rate of change. Any questions? It was a good pick. What number was this? Very good. Yeah, 53. Good. Let's continue. We still have a few minutes. So let's go back. Okay, let's look at a healing wound. I want you to see as many applications of what we're doing as possible. Okay, we are given the formula, the circumference C in centimeters of a healing wound is approximated by C of R equals 6.28 times R. R is the wound radius also in centimeters. Perfect. Find the rate of change of the circumference with respect to the radius, and then find C prime of 4 and then explain what it means. So find C prime of R in part A, in part B find C prime of 4, and in part C explain. Okay, so here's the problem. We are given the circumference function of the radius. They are both in centimeters. It's a constant times R. Can anyone give us C prime of R?
6.28
That's it. Measurement unit. So,
centimeters.
careful. Any rate of change has 2 measurement units. Always. Any derivative, any rate of change, any slope has 2 measurement units. One coming from the y value and one coming from the x value. So this is centimeters in circumference over centimeters in radius. So please remember any rate of change. You can, if I drive and you call me and you say, what is your speed, which is the rate of change of distance with respect to time, I will not say 60 miles. That will be incorrect. 60 miles per hour. Okay, perfect. C prime of 4. Plug in 4. But you can't. So it's a constant rate of change. Same measurement unit. And then explain. It's a constant rate of change because this is a linear function. And what does it mean? It means that the circumference changes with a so the circumference changes by 6.28. So the rate of change of circumference with respect to radius is constant at 6.28. Okay, let me see if we have, no, I wanted to show an example with a product or quotient, but there is no time. Any questions? Any questions? Okay, so what is due, I didn't mean that. So what is due for Thursday? Only 1.4 and 1.5. So what is left? To practice 1.6.